Hi everyone! In this video, we will graph a linear equation in standard form by plotting points. Graph the line by plotting points. 3x minus 4y equals 5. Standard form means that it's not solved for y, and x and y are on the same side. And this may end up making some of our calculations a little longer to find points that give us whole numbers, because graphing fractions isn't very accurate. Let's go ahead and make a chart for the x and y values. And since 0 is always my favorite, let's start with 0. Because we'll have lots of calculations, I'm going to try and write as small as possible so that we can fit them all in here. So we'll substitute 0 in for x, and we get 3 times 0 minus 4y equals 5. 3 times 0 cancels, so we have negative 4y equals 5. Divide both sides by negative 4. So y equals negative 5/4. That's a fraction. And to graph negative 5/4 is not very accurate, because then I would have to divide these small units up into 4 sections. So let's go ahead and try and find another number that'll work. This is the guess and check point. So I'm going to just pick another number, and hopefully we'll end up with one with a whole value. This may take some time and some patience. I'm going to go ahead and try negative 1. So we'll go over here to 3 times negative 1 minus 4y equals 5. 3 times negative 1 is negative 3 minus 4y equals positive 5. Add 3 to both sides, and we get negative 4y equals 8. Divide both sides by negative 4, and we end up with y equals negative 2. So we found a whole number. This opens up a lot more opportunities to find other whole numbers. To find the other whole numbers, we'll take the coefficient in front of the x, and we can add it to the number that we found that worked well, and add or subtract it to the opposite variable. So the number 3 is in front of the x, so we can add or subtract it to the y coordinate. So negative 2 plus 3 is positive 1, and negative 2 minus 3 is negative 5. We can do the same with the x coordinate by adding the coefficient in front of the y to the x coordinate that we found that was a whole number. So we can add or subtract negative 4 to our already found negative 1. So if we add or subtract negative 4, we get negative 1 minus negative 4 is positive 3, and negative 1 plus negative 4 is negative 5. So we can use either the 1 or the negative 5 to substitute in for the y and find the x value, or we can substitute 3 or negative 5 in for the x value and find the y. And we'll need to pick 2 of these to find 2 more points to plot to graph our line. I'm going to pick positive 1 for the y since it looks nice and easy. So we'll do 3x minus 4 times positive 1 equals 5. 3x minus 4 times 1 is 4 equals 5. So we'll add 4 to both sides, which gives us 3x equals 9. Divide both sides by 3, so x equals 3, which is a whole number. So we end up with the point 3, 1. Now we have 2 ordered pairs, negative 1, negative 2. It's getting kind of messy, so I'm going to circle that. And our coordinate point 3, 1. Going to circle that one as well since it's getting a little messy. And for our last one, let's go ahead and choose, well, let's not choose the 3 because the 3 was from the ordered pair 3, 1, which we already got. So let's go ahead and choose negative 5 for the x value. So we end up with 3 times negative 5 minus 4y equals 5. 3 times negative 5 is negative 15. Minus 4y equals 5. So we'll add 15 to both sides. So we end up with negative 4y equals positive 20. Divide both sides by negative 4. So we end up with y equals negative 5. So we have the ordered pair negative 5, negative 5. And I'm going to write it as an ordered pair. And now we have our 3 points that we can graph to graph our line in this rectangular coordinate system. Let's graph the first one. Starting at the origin, we'll move -1 in the x direction and then down -2 in the y direction. And so our first point is here. Our next point is 3, 1, so we'll start at the origin and we move 3 in the positive x direction, 1, 2, 3, and then +1 in the y direction for our second point. And our last point is -5, -5. Starting at the origin again, we will move -5 in the x direction, 1, 2, 3, 4, 5. From here, we'll move -5 in the y direction, 1, 2, 3, 4, 5. And this is our last point. I'm going to use a straight edge to try and connect all of those points as accurately as possible to get our line. Now that I have them as lined up as I possibly can get, I'm going to connect them. And here's our equation graphed on a rectangular coordinate system, and our linear equation is all done, so we're finished. I have one more tip for those who are struggling to find numbers that are not fractions. After adding and subtracting the coefficients in front of the variables, you can continue adding and subtracting those coefficients. So when we added 3 from -2 to get 1, we could have added 3 again to the 1, which would have given us a 4. Then we could add 3 again to give us a 7, all of these going into the y value. So if we've added 3 here, we would have gotten 4, and add 3 again to get a 7, add 3 again to get a 10, and these are all numbers that we could substitute in to find a point that isn't a fraction. We could also do it on the x side as well. Getting the -5, we could have subtracted 4 again to get -9, subtract 4 again to get -13, and so on and so forth. There are infinite possibilities, so you can pick whichever one is your preference.